I'm going to start the recorder. Streaming is on. All right. So the first thing is I'm going to talk about the test itself. This is what I usually call the rub salt on wound session. But it's good, okay? Rubbing salt on wound, sometimes helps, prevent any further infection, okay? So even it stings a little bit, sometimes it's actually a good thing. All right, so first thing first, I think most of the time I don't get this anymore because I made it very clear, last name first instead of first name first. So I didn't see anyone putting in the name in the wrong order. So I'm just going to do it the same way as you guys do. So student ID, there we go. As you can see, I have a pretty low value, ID, 6,000 something. I think it's up to what, 170,000 now, within that range. Okay. All right, so we'll go ahead and do the test.
So the significance of that is?
I have worked here for a long time. There are people with an even smaller employee ID, but not a whole lot. I mean, as you can see, there can be only about 6,886 people ahead of me, because I'm 6,887. Huh? Sorry?
Who's number one?
I do not know. It's whoever was. Well, I don't know. I mean, when the ID system came online, I don't know how they actually went back to assign the numbers. Maybe based on employment history, maybe something else. There was a hand question?
Actually, no, one person has a smaller number than you.
Okay.
Yeah, one professor, my ESO English professor.
Okay, what's his name? Her name?
Oh, I don't remember her name, but I know her reading.
That means that person was probably employed before I joined ARC.
Yeah, not too respected, but just for the honest.
Okay. So here's question number 1 of 4, and if your question doesn't look exactly like this, don't worry. There are 14 variations of the same question. I could have generated like 28 exactly for the entire class, but I decided, well, 14 variations is close enough. Okay, but they all have the same trace. They all have the same pattern, okay? So nobody's going to get a question that's harder than anybody else. All right, so we'll go ahead and trace this one. So we start with line number as a column. Some people brought along a ruler. Great idea. Okay, so that was good. Or you can use a textbook, or you can use something else, to line. Or if you're like me, you can just kind of draw a line too. I mean, that works. Okay, so we got line number. We have one column for comments. So for the comments, you just have to make sure there's enough room to say whether x does not equal to 25, or x is less than 25 is true or false. As long as you get enough room for that, that's fine. And then we only have one variable here, which is x. So the first row is the precondition, and we don't need to know anything about x because the first thing we do is on line 152, which is to override it with 7. Okay? So in this case, line 152, don't ask me why it is 152 because it's just a random number. So on that line, x is overwritten by a value of 7. On line 53, we evaluate a condition. Okay, x does not equal to 25 is true because it's 7. Then we get to 154. On line 54, we ask the question, is x less than 25? Yep, that is true. So we have to go to the then statement, which is on line 155. So on line 155, in this particular case, I'm adding 10 to x. So x goes from 7 to 17. Then we go back. Okay, there's nothing else to do at this point. Because once we execute the then branch, we skip the else branch, which means we get to the end of the conditional statement, which is the only thing inside the body of the while loop. So we have to go back right away to the beginning of the while loop, which is line 153. X does not equal to 25 is true. And then we go to line 55. Line 54. Okay, go back. Back one more. So we go back to line 154. X is less than 25 is true. And then we go to line 155 again. We add 10 to 17, which is 27. Then we go back to line 153. X does not equal to 25 is true. On line 154, X is less than 25 is not true anymore. This is false. So now we have to go to the else case, which is on line 157. We decrease the value of X by 1. Now it's 26. We go back to line 153. X does not equal to 25 is true. We go to line 154. X is less than 25 is false. We go to line 157. We decrease X one more, which is now 25. But we are not done yet. Okay? We cannot exit the loop and conclude at this point because we have to go back to line 153. Then we say, X does not equal to 25 is finally false. Then we are done. So we have a post here. I kind of calculated the number of lines to make sure there's enough for this one. So do you guys have any questions? No?
You forgot the tree inside the cost.
I have not decided yet. Yeah, go ahead.
Did you, on all of them, make it sure, like, if you use the lines, it would fit inside the line?
It should.
Okay.
Yep. Maybe. We'll see. I think they should all fit. Go ahead.
I feel like the number is just 1 through 6.
Why would you use 1 to 6? Okay, well, we'll see. The reason why there are random beginning line numbers is just so that if somebody is copying from somebody else, they would copy the wrong numbers. All right. So question number 2, kind of the same thing that we did with the other one. So I saw solutions in different forms, which is fine. Okay. All I really want in the question is it says specify the value of X to get to that line, but it didn't specify a single value or whether it's a range. Okay. So it didn't say a particular value. So if you give me a range, that's okay. If you give me a particular value, that's fine too. Okay. So we'll go ahead and figure out what value of X can get us to line 3. Okay. So if you get to line 3, that means X is less than 128 is true. It also means X equals to 128 is also true. That is not possible. A number cannot be less than and equal to another number at the same time. So that means it is not possible. Okay, so you have to say it not, okay, not impossible. Okay, no, not possible, just impossible. Okay, not possible, and then you have to kind of explain X being less than 128 and X equals to 128 does not exist, or something to that effect. Okay, how you want to phrase it is up to you. But you have to refer to the conditions, okay? Because everything traces back to the condition to say that, nope, it's not possible. Line 5. Line 5 is pretty easy because line 5 says X is less than 128 to get to the then portion, which is line 2 to line 6 of the outer conditional statement. But then we also want X not to be equal to 128. Well, there are plenty of numbers that are less than 128 and not equal to 128. Such as 127, right? So in this case, if you want to, you can just say, X equal to 127 is one value that can get you there. But if you want to be super general, you can also say any number of X that is less than 128 will do the same trick too. So you can, both versions will work, okay? Line 9, sorry?
I put X is less than or equal to 127.
That's fine. That will still work, but you made an assumption that X is an integer in that case, which is fine. Okay, I will take it. Line 9. So how do we get to line 9? X is less than 128 has to be false. Okay, so X is greater than or equal to 128, but at the same time X has to be greater than 98 in this case. Well, if X is greater than or equal to 128, it is already greater than 98. right? So in this case, x equals to 128 will do the trick. Or if you want to specify, in this case, x as a range only has to be greater than or equal to 128. So that makes line 11 a little bit interesting, doesn't it? Because now we are looking for a number that is it's greater than or equal to 128, and yet it is less than or equal to 98. Such a number does not exist, okay? So we'll say not possible, because in this case, x has to be greater than or equal to 128, and x has to be less than or equal to 98, and that x does not exist. Okay? So that's kind of what I expect as the answer of question number 2. You can phrase it differently. You can pick different values, for instance. But that's kind of what I'm looking for. Are there any questions about number 2? Okay. Number 3. Number 3 is all about mod and post checking. Okay. So we'll go ahead and trace this one. So we got line number. We got comments, because we have one condition to evaluate, which is x equals to 0. And we also only have one single variable x to track. So in this case, the precondition is we do not need to know anything about x. And then on line 33, in this case, x is initialized to 0. But then we have to go through the body of the loop first. We do not go straight to line 37 and check the condition. I hope nobody did that. So we go to line 35. Line 35 is adding 23 to x. X is now 23. And then we get to line 36, which is computing the remainder of 23 divided by 5. So 23 divided by 5 has a remainder of 3. So that means x now has a new value of 3. This one may actually run out of room and need a second column. So now we move on to line 37, and we say x equals to 0. Oops. X equals 0 is false, which means until x equals to 0. So we stay in the loop because the exit condition is false. So now we get back to line 35. Line 35 is going to add 23 to 3, which makes it 26. And then on line 36, we take the mod of 5, which is 26 divided by 5. We take the remainder. That's 1. We get to line 37. X equals to 0. Whoops. I keep using the wrong symbol here. X equals to 0 is false, which means we are not ready to exit the loop yet. Then we go back to line 35. We add 23 to 1, so that makes 24. Then we get to line 36. We take the remainder of 24 divided by 5, which is 4. Then we get to line 37. X equals 0 is false. Back to line 35. So it might seem that we're getting into an infinite loop, but it's not. Okay. So back to line 35. 4 plus 23 is 27. 36. The remainder of 27 divided by 5 is 2. And you can see that, at the end, or I should say on line 37, x never repeated the value up to this point. Okay? So line 37, x equals to 0. Whoops. Force of habit. Okay, x equals to 0 is false. So we get back to line 35 again. 2 plus 23 is finally 25. 25 divided by 5 has a remainder of 0. So now on line 37, x equals to 0 is true. Did we get out of the loop? And there's nothing to do after that, so we have post. I got one line left. Do we have any questions about this one? No questions? Okay, last one. Okay. Well, this one, kind of requires this piece of information. which is in the module. Okay, the top-down module talks about the, no, not top-down. This is in binary search. Okay, so searching in a sorted array actually has this symbol defined. Okay, but I guess the majority of the class did not read that module. All right, so tracing it. Line number. We have condition, so we need comments. Okay, and then once again, we only have one single variable to track. Okay, precondition. Well, we don't have to initialize anything because x gets overwritten the first time, the first thing into this code. So on line 182, we put a value of 77 into x. And then on line 183, we evaluate x does not equal to 0 is true. Then we get to line 84. So in this case, line 84 is going to divide it by 2, which is, let's see, 77 divided by 2 is 38.5, okay? But we are taking the floor of 38.5, which makes it only 38. So that's 38. Go back to 183. X does not equal to 0 is true. 184 again. 38 divided by 2 is 19, so that's pretty easy. 138. X does not equal to 0 is true. 184 again. 19 divided by 2 is 9.5, but since we take the floor of 9.5, it is just 9. Okay. Then we get to line 83 again. X does not equal to 0 is true. Line 84. 9 divided by 2 is 4.5, but since we take the floor, it is just 4 here. Line 83. X does not equal to 0 is true. 184. 4 divided by 2 is 2. So from here on, it is pretty smooth sailing. 2 divided by 1 is 1. 2 divided by 2 is 1. And then we get back to line 83. X does not equal to 0 is true. 184. 1 divided by 2 is 0.5. The floor of 0.5 is 0. Oops. Uh-oh. Don't know what happened. Okay. So this is 0. We get back to 183. X does not equal to 0 is now false. And then we get to post. Now we're done. So you might say, but some people may get an even number every single time. I get an odd number many times. I actually made the software, that the program that generates these tests to have the same number of uneven numbers or odd numbers during the process. So it's all even Steven. This is actually generated by an algorithm. So I didn't actually prepare the 14 variations by myself. Huh?
So I got a 0 on that question.
Why?
I didn't put together the floor and the symbol on there until I had turned the test, and then I was like, oh.
Oh. Okay, so getting back to the, yep, go ahead.
I'm just curious what you coded in.
I wrote this one in Node.js, JavaScript. Yeah, before I programmed using Perl, and then since this semester I wanted to learn JavaScript, so I decided, yeah, I would use JavaScript.
So is there a function that also determines how many lines to put?
No, it does not determine how many lines, but I just went through the track. I track it through my mind and go like, okay, that's about right, 20 lines. All right, so that's the whole test. Any feedback? It's all right. Okay.
Is there a way we can make up some points?
No. It's worth trying. Yes. Yes. Asking that question does not have point deducted. Yep.
Is it hit or miss? Like if you get it wrong, it's just wrong?
No, it's not, definitely not hit and miss. It's not binary. In other words, the grading is not binary. So for each one, like for this one, well, it depends on how you got it wrong. So I would still evaluate whether you got the concept of a while loop correct or not. So you can get the assignment wrong, Okay, so the behavior of the code is incorrect. But if I see that you can still evaluate, whether x does not equal to 0 is true or not, and using that to determine whether you go for another iteration, you'll still get partial credit for that. Yep.
I got this wrong because my simple math was just way off.
What?
I divided 77 by 2 and got 36. So the whole way down, I guess I was off by like 1 or 2 until the 5th iteration.
That's fine because if I look through your trace and assuming that the first step you just made a mistake because you didn't have a calculator, but everything else is consistent. Like from 36 it becomes 18, 18 becomes 9. Then you will still get most of the credit. So I'll just kind of knock one notch down, just because okay you aren't exactly the most careful, Yep. It's worth 20% of your entire grade, for the entire, for this whole class. So it's,
Which is?
well, 20% is 20%.
No, but like how many points is the final grade, or like our total grade?
Okay, so exam 1 is 20%, which is this one. Exam 2 is 20%, and then the final exam is 40%. All of the homework assignment add up to only 20%. So there will be more homework assignments later on. So missing one homework is not the end of the world, but missing the final exam is gonna hurt. Yep.
Is there a way we can like get some extra credits throughout the
I am not known for extra credit. Yep.
you wanna get you wanna be known for that?
No, absolutely not. Absolutely not. If you want to tell your friends, tech, is so tough, he's so hard, he doesn't give extra credit, please advertise. Yep.
What is the point value for the entire course? What's the point value for the entire course?
100%. Everything is proportional, right? It's just proportional.
1,000 points, 100 points, 500 points?
What? Percentage. It's all percentage. Okay. Yes. Uh-huh. Uh-huh. Okay, hold on, guys. Okay.
Number 2, I didn't put x equals because it says it's in the question. It states for x. So
If you specify a value and it works, I can count it in. Yeah. So you don't have to say x equals 2. Yep.
Each question in that test is how many points?
Okay. Did you read the beginning of the test? They all carry equal weight. So it doesn't matter because it's okay. Okay, so it looks like we need a prerequisite for this class to read the syllabus, right? Okay, so how many questions do we have? You just took the test. There were 4 questions, okay? There were 4 questions, and they all carry equal weight to account for 20% of your final grade. So each question accounts for 5% of your final grade. Does that make sense? Okay, so picture. Okay. 20%. Okay, all right. This is the final exam. This is the first exam. This is the second exam. These are all the homework assignments, okay? All right? Oh, you're right. I need to record this. I think I got it recorded. Yes, okay. Huh? This is all in the syllabus, okay? This is not new. I did not invent this today. All right, but the picture is not done yet because somebody asked, what about the questions? How much weight does each question carry? Chop up that pie, okay? Chop up that section. Huh? What? Oh, okay. Okay, there we go. So chop up exam 1 into 4 equal portions. So each one is 5%. There we go. Yes?
This is the first time that this has ever happened in your class?
No, with cisp300, it happens quite often.
Really?
Yeah. Yep. Sorry? This class has no prerequisite, but this makes me think that I should specify a prerequisite. Huh? Oh, really? Ah. What prerequisite do they put on this? 120? And what is math 120? What?
I'm doing math 120 right now.
What is math 120?
It's just basic algebra.
Okay. All right. Well. So anyway, but you guys don't care about this pi because you only care about whether you pass this class or not, right? So 37.5% is the minimum to get a C out of this class. It's in the syllabus. It is in the syllabus. From day 1 of this class, it is in the syllabus. Okay, 37.5% is what you need to pass this class. And you can see the final exam by itself is 40%. So if you ace the final exam, you're home free. You get at least a C out of this class. Okay? Huh? So the final exam has twice the amount of time compared to this particular exam, so you can expect it to be a little bit longer, right? Yep.
So you're telling me if I pass two of these exams with 100%, I pass the class?
Yep, correct. You can you can ace one of the exams, do all the homework, and then you can still pass the class. Yes. Typically, people who get perfect score in the first exam, are not the type who go like, do I barely have enough points to get a C out of this class? If so, I'm just gonna not continue with this class. Those people tend to, take the second exam and take the final as well. I have not decided. But they all add up to 20%. They all add up to only 20%. Yes? Yes, we'll go over the homework assignment now. Okay, very good. All righty. So we'll go over the homework. All righty. So let's go ahead and review the homework assignment first. What is it asking? And then we'll talk about how to get it done, okay? So the homework assignment is about finding the length of the longest run in an array, and the run is defined as, okay, consecutive elements in an array that have, same values, okay? And I gave you an example here, okay? So we have, okay, can I continue with the class? Thank you. So we got 3, 4, 3, 3, 4, 2, 3, okay? So the longest run is the 2, 3, but I only care about the length. The length of that run is 2, okay? So we got a few ways to do this. One way, which is kind of not so efficient, is to have a double loop. So you have an outer loop, and then you have an inner loop. The outer loop says, okay, I'm assuming this is the beginning of a run, and then the inner loop goes, okay, how far can I push it as a run? Not really efficient, but it will get the job done. Okay, so we'll talk about that too. The second method is not to use a nested loop inside another loop, is to use a conditional statement inside the loop. So that way, you're basically looking at one element, and you ask the question, is this element continuing a run? If it is continuing a run, then you add 1 to the length of the current run. If the length of the current run is more than the length of the maximum run up to this point, then you update the length of the maximum run at the same time. Okay? What if the current element is discontinuing the run because it's different from the previous element? Then you just go like, oops, okay, this is the start of a new run. Run length is now 1. Okay, so that's kind of how you can do this homework assignment. All right, so we'll go ahead and write the code to do this. Okay, and for this particular one, you kind of have to know that certain things you definitely need. Okay, so you know that you have to compare a bracket I with a bracket I plus 1 or something along that line, because a run depends on whether a particular element is the same as the one before. Okay, so something along that line, you have to compare two array elements for sure. Okay, it may not be adjacent. Okay, if you have a double loop concept, it's not going to be adjacent. So you can use. Do you guys just want me to give you the solution? Because okay. Okay. Question?
No, I was going to ask if you could write the while loop, like both of them.
Okay, I can write both of them. So we'll do the short one first, okay? The one that is kind of super efficient because you only have to go one pass, okay? So in that case, n is, we can assume n to be 1, okay? Because unless you have an array with no elements, which doesn't make any sense, then n has to be at least 1. And then you have a index to control which element you're looking at in the array. And that one, interestingly, I would initialize it to 1. Oops, wrong notation. I don't want to use equal symbols to be consistent with the class notation. So use a left arrow to mean assignment. And then I is going to be initialized to 1. And then what we do is we also need to keep track of the length of the current run. So I would use R for that purpose. Okay.
Can we store value to 0?
Huh?
Can we store value to 0?
You can, but this is my solution, so I get to decide. Yep. So now your loop is to basically say, as long as I have not scanned through the entire array, I will keep going. Okay. So that means that as long as I is still a valid index, which means I has to be less than bar a bar. Okay. So this is how I stay in the loop. So when you're in the loop, you basically have to look at the element at index I and ask that question. So you basically ask, is the element at index I, does it equal to the element at index I minus 1, the one right before that? Okay? Because if it does equal, then you are continuing a run. If it is not, then you're starting a new run. Is that okay? So let's say it is. Okay? If a bracket I does equal to a bracket I minus 1, that means this particular element at index I is continuing a run. Well, if you're continuing a run, then you just say R gets R plus 1. Because the run that you're continuing is now, the length is 1 more than what it was. Okay? Then you have to say, well, is this R greater than n, which is the length of the longest run up to this point? If it is, then you just have to update n to be R. Oops. And if here. Okay. I think that's the only thing you have to do for the then statement. So now we look at the else statement. In other words, what if a bracket I does not equal to a bracket I minus 1? So that means you're starting a new run. Okay. What do you do when you start a new run? R is reinitialized to 1. Okay. And there's not much else you have to do. You don't do a single thing about n because n is the maximum. So you can only bump n up when you find something that's longer, but otherwise you leave it alone. Okay. So now you have an end if, and then after the end if, you have to increment I. Otherwise, it becomes an infinite loop because you'll be looking at the same element over and over again. And then you have end while. So that's one solution. So this solution is fast because it is a one-pass kind of solution. It only has to go through the array exactly once. It has to look at every single element just once. Is that okay? Now, this thing can actually exit even earlier because if I plus n up to this point is greater than bar a bar, you can get out right away. because whatever run you're in cannot be longer than the longest run that you have seen already, because you run out of index before you run out of that length. Okay, but I'm not going to optimize for that. Okay. The second way to do this is to have a double loop. So if you use a double loop concept, you can still initialize n to 1. Okay, and then you need 2 loops this time. So you have, let's see here. Okay, so I is going to start from 0, and then you say while I is less than bar a bar, do the following. In other words, I is controlling the index of the first element of a potential run. Okay, that's the role, the job of I. Okay, so in the loop, the first thing you do is you reset R, which is the length of the run that you're currently looking into. You reset it to 1 because we have at least one element in that particular run. Is that okay? Then you have another loop inside this, another while loop here, and you basically say, let's see, that will work. Okay, so in this case, you have to basically say, as long there are two criteria to stay in this loop. The first thing is you have to make sure that I plus R is less than bar a bar, because this way you're not going to run beyond the end of the array. Okay, if this is true, then you also have to make sure that a bracket I, which is the beginning of the run that we are looking into, is still the same as a bracket I plus R, which is the element that we are looking at, the last element in the run that we are examining. So as long as it's the same, you can still increment R by 1. Okay, so if this is right, then R gets, let's see, I'm just looking at this and go like, R is 1 to begin with. If that is the case, well, let's do a R gets R plus 1, because I think it's going to increment 1 too many times, but that's okay. We can adjust later. So and while. Okay. Yeah, I think that will work. Yep, that will work. There we go. Okay, so when we get out of this loop, it can get out because of one of 2 reasons. One is I plus R is no longer less than bar a bar, which means we don't have any more elements to look at. And the second one is a bracket I does not equal to a bracket I plus R anymore, which means we have hit the end of the run, so we have to stop. But regardless, R at this point is going to tell you what is the length of this particular run starting at index position I. Okay? So now you have to say if R, which is the length of this particular run, is greater than n, which is the length of the longest run discovered up to this point, then you have to update the maximum. So the maximum reflects what you just found. And if. And then you have to increase I by 1 at this point, and while. So that's the second way to do it. Now, your code doesn't have to look exactly like this, but the logic has to be there. Is that okay? Now, there are some other ways to do it too. Some people like to look at things backwards. You can always start with the last index and work your way back to 0. It's just kind of awkward, but it works. Yep.
Are you going to leave comments on the homework to tell us if we get it wrong or what we could do better?
That's a good question. I have to take a look at what kind of submission I'm getting first. Because sometimes a solution may be really close, then I go like, yeah, I can kind of give you a pointer. But sometimes the solution is too far off, so I can't really say, okay, fix this, and fix this, because Yep, exactly. So I kind of have to look at what people are turning in first to decide how I can respond to that. Okay. Yep.
With the conditional statement version,
Mm-hmm.
if you were to initialize I to 0, would you do I is less than blah blah minus 1 and then compare it
You could do it that way too, but the way I look at this is, I controls, the element that may extend a run, and that's how I look at this. You can always shift the index by 1. Okay, you just have to readjust the boundary condition and what you're comparing to. Yep.
So can you explain what the difference is between your logic and the logic that she just used in that we initialize I to 0,
Yeah.
and have bar a bar minus 1
Sure.
being the condition of an array when I is less than, and I is always incrementing with 1 at the end of the if then else statement?
You can just shift everything by 1, so you can initialize I to 0, but then when you compare, you also have to make sure that you compare to bar a bar minus 1. But the rest of the stuff, you have to readjust everything too.
A bracket I plus 1.
So a bracket I is not a bracket I anymore, it's a bracket I plus 1, and then you have to erase the minus 1 here, because you're shifting everything by 1. That's all you're doing.
Is a bracket I the same thing equals a bracket I plus 1 the same thing as what you just wrote there, right?
Because the red line is indicating what you need to adjust when you initialize I to 0, because all you're doing is you're shifting everything by 1. So if I is starting with a value that is 1 less than what I have here, then every place where you see I, you have to basically say, okay, we have to add 1 to that expression.
But if a guy wrote a bracket I bracket equals a bracket I bracket or a bracket I plus 1 bracket, it's the same thing as what you have there, right?
Yes, because the comparison for equality is commutative, which means you can exchange the order. Yep. Yep. All right. So, did you get it close? Did you get it right? Exactly that. Good job. That is good. All right. So, how was this homework assignment? Was it easy, difficult? Okay, because you really have to kind of think about the structure of the logic. You have all the pieces, but the question is, how do you put the pieces together, so that together it works? So, well, I'm kind of glad that you guys find this kind of useful. And but this is basically a taste of developing algorithms. Okay, because this is like you're thinking about how to solve the problem. You do it by hand first, okay, and then you try to capture the logic of doing it by hand. And this basically is abstraction. Okay, did I talk about the word abstraction in this class? I think I did, yeah. So this is basically abstraction because you're basically looking at examples of how to do it by hand a few times, and then you're thinking about, okay, but what is the essence? What is the framework? What is the skeletal, things what is the logic of doing this? Okay, and that is basically the essence of, programming or developing, programs. In software engineering, not just programming. Sometimes we have to come up with, what we call class hierarchy and stuff like that. That is all abstraction. It's all basically about losing details and capturing the essence or the patterns of things. So it's about recognizing patterns. Is that okay? Because I do want to kind of point out, what kind of activity is needed in order to come up with algorithms. Okay. All right. So, yep.
I didn't quite get my question answered, though. You said that you were comparing an element and the one before it, and I was comparing the first element with the next one, that one with the next one.
Yeah. Yep. That's fine. I mean, it's just a perspective issue, right?
So it's just perspective, so we're doing the same thing.
Yep.
Cool. Sorry.
All right. Cool. So now we can get back to subroutines, which was the last topic that we talked about on Monday. And it's this particular module here. So remember to read the modules. So it's not really just what I talk about in class. You also have to kind of read the modules, because sometimes, like this is in the module, but in class I only talked about the floor function. So you kind of have to read the module to understand the symbol is this, okay, for taking the floor of something, okay? Yep, exactly. Yep. See, that is abstraction. That's the application of abstraction. You're basically capturing the essence of the floor symbol, and then you're extending that abstraction to, oh, if I want to take the ceiling, using this understanding is just going to be on top, right? So that's good. All right. So now we're getting into subroutine. And then what we'll do is we look at this code here, okay, which is something that we looked at the other day. And then we'll go ahead and trace it, okay, because it doesn't really do anything useful. This is kind of the trace, okay, so I have the trace already documented in the module. But instead of just looking at this, we are going to look at this, and I will do it interactively in class. And this is one of the interesting part of this class is most other classes, most other people who teach cisp300 will not tell you what is going on when a subroutine is called, okay? But I do want to show you what happens when the subroutine is called, because it is really important in your later classes. If you don't get a good handle of this stuff here, you can still get by in some of the programming classes, but once they hit recursion or something that's complicated, then it's going to be like really hard because you just run into a brick wall. So, all right. So in this case, recursive means a subroutine is calling itself. You're invoking a subroutine from itself. But the mechanism of invoking a subroutine does not change. Whether you're calling it from outside or inside, doesn't really change it. Okay. So we'll get to recursion soon enough. So when we get to it, we'll talk about it. In this class, yep. So in this case, we don't have any variables to track. So apparently, there's nothing to track to begin when we begin this. So pre has nothing to say. We do not have any local variables whatsoever. The first line that we execute is actually line 4. Okay, I cannot say what line 4 is going to do because it doesn't tell me. Okay, it just says here, do something before invocation. Okay, whatever it is. Okay. And then we get on to line 5. This is where things get a little bit interesting. So when we get to line 5, we go like, okay, we are going to invoke ABC, which means whatever ABC has, we want to do that now, okay? And you can see ABC is a subroutine. It is defined on lines 1, 2, and 3. The definition is over here. So ABC is a name of a block of code that I want to do now because I'm invoking ABC. All right? So getting there is not a problem, okay? Because the name ABC uniquely identifies the subroutine ABC, so I don't have a problem getting here to do whatever is here. The problem is getting back, okay? When you're done doing whatever is inside the subroutine on line 2, by the time you get to line 3, the question is, where are you going back to? How do you know? Okay? So what I do here is I use a new column in the spreadsheet. I basically create a new column. I allocate a new column called return line number. And that column has only one job to do. It is basically saying, what is the line right after this particular invoke on line 5? Well, that's an easy one because the invoke is on line 5. So when we get back, we have to continue on line 6. Okay? So we say, okay, the return line number is line 6. So now we have left behind a piece of breadcrumb before we enter a diversion in the forest. Is that okay? So that by the time we get back from that diversion, I can look at that piece of information and go like, oh, which way am I supposed to go next? Ah, here's a little bit of information to tell me how to proceed after I get back from that little diversion. Okay? So now we get into the subroutine. Okay, so the subroutine doesn't do anything, so we'll say line 2 is the next line to execute, but I cannot really say what it's doing because it just says something is here. Okay, we'll do something. So when we get to line 3, okay, then you go like, well, don't we usually do not track and something like and if we don't track, else we don't track, and while we don't track. So how come and define sub is important? Well, that's because it is marking the end of a subroutine, which means I better figure out where I need to go back to. Okay? So what do I do to get back to where I left off or where I came from? I look up the rightmost return line number column. to tell me where I'm supposed to go back to. It tells me I'm supposed to go back to line 6. So now I got two things to do. The first thing I need to do is to say, I'm supposed to get back here. But do I still need column B at this point? No. Once I get back to line 6, I don't really need column B anymore. So that means that column can be reused later on if I need to use that column. Is that okay? So the way I represent it here in the spreadsheet is I just copy and paste return line number, except, okay, I need to use my bifocal because it's hard to read this stuff. It's okay, you guys will all get to this point. It is inevitable. You're already there, okay. All right. It has to do with the hardening of your lens, okay, so I have 20/20 vision after correction. It's just that I cannot change the focus. Yep, that's pretty much it. Okay, so this is, so the strike through is indicating this column B, is no longer in use. Okay, I have used up the information here already, and it is no longer used. So now I can continue execution on line 6, do something over there, and then we get to post. Yep.
Column B doesn't have any kind of line number indication, so how do we label that if we were to?
Column B itself does not have any line number because it is allocated. We start to use column B on row 4 of the trace. In other words, when we get to line 5 of the algorithm, we say, oh, we need one extra column to remember where to get back to when the subroutine is done.
So if we were to trace this plus additional code that would include like whiles, or if there were conditional statements, would we use C as our comment column?
Then you would need, I would put the comments column between A and B, because anything that's static is going to be on the left-hand side, and anything that can dynamically change is going to be on the right-hand side. So comments, the tracking of any variable that is static is going to be on the left-hand side. And then later on we'll see there's a lot of stuff that we dynamically allocate and deallocate. All of that stuff is on the right-hand side. So we can say allocate, 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 deallocate, 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 that sort of thing. Okay? So we got 5 minutes left, 6 actually. So we can move on to the second example, because this one doesn't really show the magic of calling and returning, but this one, so this is the formalization of all that stuff, so you need to kind of read about it. So multiple invocation is something like this, okay? Maybe I like to do all that stuff in ABC so much that I want to do it twice, okay? So I can invoke it twice, right? So the problem with the importance of invoking it twice is I need to, so on line 5, the first time I invoke it, I need to remember that it needs to get back to line 6, right? But when I get back to line 6, that invocation has to remember that we have to get back to line 7. And they're both going to reuse, they will both use the same column. So the same column is used, deallocated, and then it will get reallocated and used again, and then deallocated again, okay? So we'll go ahead and track this one down, okay, and figure out what it looks like in terms of the trace. Okay.
So do you mean like on line 5, you call the subroutine, it starts running, and then it has to, while it's running, it continues from line 6, but then on that example, you call another subroutine and starts running too? So on line 5 of that, you call the subroutine.
Yes.
And then it starts going.
Yeah.
While it's going, it has to move on.
Not while it is going. So, okay, so let's trace this, track it down, and then we'll talk about it, okay? So I think I understand what you're asking, but we'll go ahead and do this first. So the first line we execute is the first line that is outside of the definition of a subroutine, which is line 4 in this case. I cannot say what line 4 actually does because it doesn't really specify, and then we'll get on to line 5. So line 5 is the invocation of a subroutine. So what we do is we allocate a column called return line number, just like before, and then we write down the line number that invocation. Excuse me, can I finish the class, please? Okay, so if you guys really have something to talk, we can talk outside. If you have a question to ask about the class, you can ask the question. Is that a deal? Okay. So in this case, we allocate column B for the return line number. And at this point, because the invocation is on line 5, when the invocation is done, it has to go back to line 6. Okay? So we write down 6 here to basically remember when the subroutine is done, we have to go back to line 6. Then what do? We go to the subroutine. Okay? So we continue execution in the subroutine on line 2. What line 2 does, I have no idea because it's not specified. Then we get to line 3, which is the end of the subroutine. So at the end of the subroutine, we have to get back to whoever was invoking me in the first place, but not to get back to the invocation itself, but the line after the invocation. So I look up the return line number column that is the rightmost, and it says, I'm supposed to go back to line 6. So now we go back to line 6 here. So line 6 is the next line to execute, but at the same time, I have to deallocate this particular column because it is not useful to me anymore. So I use the strike through notation to mean this column is now deallocated. Now I'm on line 6. Question?
Yeah,
Yep.
So the tracing can't trace the subroutine unless invoked?
Correct. So a subroutine, unless it is invoked, is completely, it's just a definition, but it's not used. It's just like in a dictionary, we have thousands and thousands of definitions of different words, but until I use that word in a sentence, you don't need to know the definition of those words. And it's the same thing here. Until a subroutine is invoked, you can have like 20,000 definitions of different subroutines. But until you have an invoke, those definitions don't do a single thing. Yep?
Why are we tracing line 1?
Because line 1 doesn't do a single thing. It is really just the marking of a beginning of a subroutine of the name ABC. Okay? Okay, so here's the important part. On line 6, what are we doing? We're invoking ABC again. So what do? We do the two things that we need to do. We allocate a column, okay? We allocate the leftmost available column. And then we use it to remember where we're supposed to get back to. Okay? So which column is the leftmost available column at this point? Is column B not column C? Because column B was deallocated on row 7 of the spreadsheet. So it is once again available at this point. So column B is now the leftmost available column. So we'll reallocate it to remember the return line number. But the line number that we need to remember is no longer 6, because the line number right after the line 6 invoke is line 7. Yep.
So you're implying that the leftmost available column is B right now. So if we had a subroutine that called another subroutine with the leftmost column, that would be in use during that first subroutine with
Correct.
C.
Yep, exactly. So in that case, it's called a nested invocation, which means you're inside a subroutine that was invoked by somebody else, and then you invoke again. So now you have to allocate column C because column B would still be in use at that point. Yep.
With an invocation, a nested invocation, would the return line be the beginning of the subroutine that initialized the second subroutine?
No, the return line number is always relative to the invoke itself. So in this case, because the invoke is on line 6, so the return line number is line 7. Okay? So now we go into the subroutine, execute whatever is on line 2, then we hit line 3 again. But this time on line 3, we are now looking for the rightmost return line number column. Well, it is column B again, but this time it is telling me not to go back to line 6 because the current return line number is line 7. So this is how I know in the second invocation, at the end of that, we have to continue on line 7. And once again, we have to remember to deallocate the column because that column can come in handy later on. Okay? So after line 7, there's nothing to do, so that's why we put a post there. So this is really, really important because the key is how do we remember where to get back to from a subroutine. Going to the subroutine is easy because there's a name, right? Invoke ABC, And there's the definition of ABC. That one is easy. How to get back is the difficult part. Yes? Question? There was a hand. Yep.
So you said, what did you say, leftmost column or rightmost column?
In what context?
So with 5 and 6 invoke and invoke,
Uh-huh.
allocate the allocate.
So when you are invoking, you allocate the leftmost available column.
Which would have been D, that's why you started with D, right?
Right. But when you are at the end of a subroutine on line 3, then you locate the rightmost return line number column that is in use.
And that still ended up being B because.
In this case, yes, because we don't have any nesting in this case.
Because the subroutine ended itself, right?
Correct.
So if the subroutine had a subroutine inside of it, then it would have been C.
Kind of like this. So we don't have time to go over this today, okay? But you guys need to read ahead of time so that on Friday we can talk about this. And if you read ahead of me, then we can talk about this, in a kind of more timely fashion, okay? So this one is nested because ABC is invoked from outside, but inside ABC it is invoked DEF. It invokes DEF, so now it is nested, okay? The trace is actually already in the notes in the module, but I will go over this on Friday, okay? But if you read ahead of me, that will make it easier, okay? Because you have to kind of clear away the concept for today first to get to this part.
But you know it's not explained to me, explained
Huh?
You know it's not explained to me, explained to us, right?
The reading part is important, okay? If you
Give him a hard time, so.
all right.
Thought I had some questions, but no